Hello, my name is Lotus Zhang. I'm presenting our paper, Designing Accessible Obfuscation Support for Blind Individuals' Visual Privacy Management on behalf of my co-authors, Abigale Stangl, Tanusree Sharma, Tseng, Inan, Danna Gurari, Wang, and Leah Findlater. Blind individuals commonly share photos in everyday life. To access visual information, socialize, keep memories, express themselves, and so on. However, a major challenge they experience is identifying and removing private objects or information from photos that they share. Recent research has begun to explore privacy protection features for blind people to manage their visual content. One promising approach is to leverage computer vision to identify and obfuscate private photo parts. Here, obfuscation refers to the process of making these private parts obscure, such as by blurring or blocking them. However, blind people expressed concern over whether obfuscation decisions made by computer vision methods would align with their intention and desired more control over the process. Based on these understandings, we focus our research on the following questions. When given the opportunity to apply computer vision methods for managing private visual content in photos, what are blind people's mental model of these methods? How do they approach these computer vision methods and why? What design opportunities exist to reduce friction in blind people's experiences with these methods? To understand how computer vision methods may or may not support blind individuals' privacy management needs, and explore tool designs that enable more control and accessibility, we prototyped a mid-fidelity screen reader accessible obfuscation tool and evaluated it with 12 blind screen reader users. We designed our prototype to support blind users to non-visually apply, manipulate, and evaluate obfuscations on private photo areas. The prototype consists of two main components, an Explore Image section and an Edit Image section. The Explore Image section first presents users with a high-level photo caption. For example, the high-level caption for this example image is 3 mangoes on a white paper in the middle of a wood table. The white paper shows several lines of small blurry text. It also provides a touch-based explorer for learning photo layout. As users touch different areas of the photo, object names and text surrounding the area are announced. As in this example, when the user touches the middle of the screen, the prototype will speak 3 yellow mangoes on top of a paper document. The Edit Image section provides a range of obfuscation choices for users to choose from. Users can choose to apply obfuscation to a list of potentially private options as detected by the prototype. They can choose the style of the obfuscation, such as blur, blackout, or erase. And they can configure the obfuscation area either to fit the exact shape of the private object or to be a bounding box fully enclosing the object. We prepared 2 versions of this mid-fidelity prototype. First, a Wizard of Oz version with functionalities pre-configured by researchers for probing design feedback without distractions from algorithm inaccuracy, and an off-the-shelf version that were implemented with off-the-shelf models to explore how inaccuracies in these models may influence participants' use of such tools. Please refer to our prototype demo video and the paper for more details. We invited 12 blind participants to try out both versions of our prototype in a 90-minute remote study. During the study, participants were instructed to familiarize with the prototype and use it to obfuscate a range of photos. Participants first went through in-scenario tasks. For each task, they were randomly assigned a version of the prototype to obfuscate photos from existing datasets that contain one of the 5 especially concerning private object categories: medical, financial, personally identifiable, and impression management related information, as well as faces. Participants then had the option to upload a photo that they took themselves to obfuscate through our prototype. Throughout the photo obfuscation tasks, participants were instructed to think aloud and were asked to share about their obfuscation decision process, their experience with obfuscation interaction, and design feedback. Our analysis revealed themes related to blind participants' understanding of visual obfuscation concepts, their obfuscation workflow, decision-making process, as well as frictions that they experienced with the prototype. Due to the limited time, we focus on giving an overview of their experience with the prototype and presenting frictions commonly mentioned by participants. Overall, participants found the prototype intuitive to operate and felt that the concepts involved in obfuscation generally easy to understand with proper verbal descriptions. Participants were able to use our prototype to interpret and manipulate visual obfuscation details. They commonly based obfuscation decisions on the level of privacy protection provided by an obfuscation option, as well as its effects on original photos' visual and information delivery goals. Still, they encountered a range of frictions in reviewing and obfuscating the photos. The most common frictions participants experienced include inaccuracy with off-the-shelf models, ineffective obfuscation descriptions, and cognitive load. First, we observed that all participants were sometimes misled or confused by captions generated by the off-the-shelf models. Inaccurate captions led to the most confusion when describing an obfuscated part of a photo. Participants found it surprising that the caption model attempted to identify blurred, blackout, or distorted area as objects, and in doing so producing false positive object detections. P10 shared, "It is kind of strange how it's different depending on which way you hide it. More things are appearing." Participants were sometimes unsure what the system actually did and thus were hesitant to share the photo. As P6 shared, it's hard to tell, what is accurate and what isn't. Another friction has to do with ineffective descriptions of obfuscation. Our prototype communicates obfuscation effects through a high-level caption and a touch-based exploration of the resulting photo. While most participants reacted positively to this approach, we learned that it did not fully support their interpretation needs. 9 participants experienced challenges in locating and evaluating obfuscated areas. 6 participants also found that object descriptions did not provide the most effective information for them to determine whether the effect there was applied successfully, as P6 said. In particular, they didn't know to what extent the obfuscation had hidden the private information. As P12 shared, "I wouldn't feel very comfortable because I'm not sure how blurred out this image is. I'd need some kind of reassurance." Finally, some participants experienced high cognitive load in exploring and obfuscating the photos. For example, P1, P5, and P12 all found themselves losing track of previously reviewed obfuscation results after trying out numerous options and navigating the detailed and sometimes inaccurate descriptions. As P5 said, I chose so many options, I couldn't tell anymore what I wanted in what. That part was a little overwhelming. Participants have proposed directions for future design ideas to address these frictions and were hopeful that with such improvements, AI-assisted obfuscation tools would support their agency in private visual content management. Here, we will briefly summarize some of the key ideas. In our prototype, users can choose to obfuscate any items that the prototype detects to be potentially private in any specific style that they desire. While participants generally appreciated the level of user control, a main design feedback from them was the option to freely make obfuscation selection without being restricted by AI, especially given the likely inaccuracies and because that privacy is contextual. Future tool design should consider the role of AI in accessible obfuscation support beyond an implementation aiding role that makes all decisions for users, but also alternative roles such as those that only suggest obfuscation ideas and provide information as needed. Future tool design should also consider ways to better guide blind users to understand the results of an obfuscation. Our study revealed a set of key information to blind individuals' interpretation of obfuscation results that are currently under-supported, including but not limited to the visibility of obfuscated private information, accurate and comprehensible descriptions to the appearance of an obfuscated area, identification of key differences between the original and obfuscated image, and so on. Computer vision models are known to work less accurately with blurry or dark photos taken by blind individuals. And in our study, obfuscated areas often resulted in false positive object detections. Future work should consider developing models or pipelines that are able to identify obviously obfuscated area rather than attempting to classify those pixels as non-obfuscated objects. Thank you so much for watching our presentation.